Here's a bit of information about the Desmos activity, Math 115, Unit 5B. This is the info from screen 2. We're headed toward compound interest, and so there are a certain number of compounding periods each year, and I wanted you to just organize the vocabulary along with the values of n for the compounding periods. So it should have gone annually, which is once a year, semi-annually, which is twice a year, quarterly, 4 times a year, monthly, 12 times a year, daily, 365 times a year. Sometimes you'll see this as 360 if an institution takes 5 bank holidays, for example. We spend most of our time in these categories up here, but occasionally you'll see something with daily in it as well. In screen 3, that's the one with my mom. That really is a picture of my mom on there. We need to take her $25 summer savings in 1941 and adjust it to today's dollars for 2.5% annual inflation. That's an application of compound interest. So the compound interest formula is coming your way. Looks like this. This value that we get out is the initial value plus all of the earnings on top of that. So in this case, all of the inflation. This P value is the initial amount. In our case, it's my mom's $25. R plays the same role as it did in simple interest. N is the number of compounding periods per year, and T is always time in years. When we fill this in for my mom, $25, 0.025 is our interest rate. Inflation will be computed annually, so our N value will be 1, and 80 years have gone by. I always encourage you to multiply the two components of the exponent together. 1 times 80 is just 80. Do that right away, get it over with, and then use that new exponent forever. If I do this calculation on my calculator, I get about 180.2391 after I make a mistake. So we're talking about $180.24. That is this $25 in 1941 adjusted to 2021's dollars. So then we had a conversation about whether, a 7-year-old is really doing pretty well at the end of the summer with about $180. It was mixed voting. That's screen 3. Inflation will be compound interest. Screen 4 is another idea involving compound interest. It is this one. If we had $2,000 today and we put it in an account that earns 4.2% compounded quarterly, what's the future value in 5 years? That means the value of the account way off in the future. You'll sometimes hear this called the maturity value also. So off we go with the compound interest formula again, and then we fill in all the pieces. The value today is $2,000. Here's our interest rate. Quarterly means we're dividing by 4 and also have a 4 in the exponent, and 5 years are going by. Go ahead and do that exponent and then do the computation. I think we'll get $2,464.66 total in 5 years. And then a follow-up question, how much interest was earned? I'm not sure that was on the slide. It might have been, but I'm not sure. How much interest was earned? Take the end value and take off the start value. So the $24.64.66 minus the $2,000 that was invested, and we'll get $464.66 in interest. And that's not talking about any taxes that would be applied to that. That's just the pure interest that comes out. We have one more application of compound interest, and that one is on screen 5. So for that one, we have a situation where we want to have $12,000 available in 8 years. And really the question is asking us to complete the statement. Invest this much now at 5.4% compounded monthly to actually achieve this goal. We get the hint that it's got compound interest in it because of the compounded monthly component. And I did this one in 2 different ways. So let me cover up one way. This is a very fancy cover up. There's my calculator hiding that. This left-hand side, this is the way I tend to do it. I fill in the compound interest formula with all the stuff I know, but I don't know the p-value. So everything else goes in. There's the $12,000 future value. There's my interest rate. There's the monthly action and 8 years going by. To get that p-value by itself, I divide both sides by that very strange looking quantity in parentheses raised to the 96. So I do 12,000 divided by, and then I start parentheses on my calculator. 1 plus 0.054 divided by 12, close those parentheses and raise it to the 96. And my plan is that we'll get $7,798.07. This is less than the $12,000. That's good news. It means we went in the right direction because we want to let interest work for us. So invest some amount today and let it grow to $12,000 in 8 years. So this is kind of how I do it, but I do have a crew of students doing it slightly differently. They take their formula and they solve it for P first. So that's what's going on over here. So covering up this side now. To get that P by itself, they want to divide by that parenthesis part right away. They do the division on both sides, and they get the P all by itself. And then they fill in the left. They're going to put the $12,000 up top. The R will be 0.054, the N will be 12, and the T will be 8. And looks like I didn't finish that format because it looks just like this over here. And we should all end up at $7,798.07. You can choose which way you like to do that problem. It doesn't matter to me. I kind of like it if you'd have two different ways to do it. And that way you'd be able to say, yes, I have this correct. So that was an intro or some components of compound interest that we want to know about. One of the sticky parts in this unit is trying to decide, like, which kind of interest are we talking about? And so screen 6 and screen 7 try to separate those things. The ones you want to check in screen 6 for simple interest will be finance charges on credit cards. Components of payday loans, those will be simple interest. And then if it says simple interest in the statement, that for sure needs to be selected as well. So there was one statement in that list where it said simple interest a couple times. That's a big clue. And then screen 7 asks you to pick out which scenarios involve compound interest. The one where it asks you about a total value if we're using 3.8% interest compounded annually. That compounded word is a clue for us. When we adjust a new car cost to today's dollars, like the new car from 1960 to today's dollars, that is an inflation scenario. Annual inflation will be compound interest. This is like the problem about my mom. So compound interest there. Then I had promised that we would talk about average daily balances. And so screen 8 is about that. And I need you to hear me. I will not put a problem where you have to fill in the table on the quiz, but I do need you to have kind of a feel for where things come from. So I think I just made this look how I don't want it to look. I think this will be what I'm working on. Let me put my visualizer back up though. I needed to grab the dollar amounts. I need to know what's happening. So let me just borrow these. We had a $250 remaining balance on September 4th. Oops. We have a purchase of $95. And so that goes against how much that person owes. When they return $12, I'll just mark that as negative. That's in her favor. And then there's another $20 purchase, and then there's a $25 purchase. So I grabbed those from the written statements. In the table, let's see, we don't have to do this part. We need to go find new balances. If she starts at $250 and then adds on $95 more of debt, this will be $345. So $250 plus $95 lands us at $345. When she returns something, the $12 is in her favor, so we'll do $345 minus 12 for $333 for her new balance. Then she charges $20 more, so $333 plus 20 will get us to $353. And then charges another $25 worth of something. $353 plus another $25 is $378. 25. Yep, I think so. So on any given day in the month, if she were to go and check her balance with the credit card company, she should be seeing one of these numbers in there, depending on which day she is checking. We need to know the number of days that each balance sits there, and that's like looking at the gaps between these dates. So from September 1st up to September 4th is 3 days going by. You can think of it as 4 minus 1 for 3 days going by. It changes on the 4th, so the 4th up to the 10th is 6 days. Changes on the 20th, so the 10th up to the 20th would be 10 days. The 20th up to the 25th is 5 days. And then September has 30 days altogether. So it might be tempting to say, oh, this is another 5 days right here for the 25th through the 30th. But look what happens. If we add these together, we get 10, 20, 29, and there are 30 days in September. So there's a little hiccup, and the hiccup is right here. For each of these other jumps, I said September 1st to the 4th, not through the 4th. This is September 25th all the way through the 30th. So if we counted out 25, 26, 27, 28, 29, 30, it'd be 6 days. That's where the little hiccup is. And that's a sticky spot. We have to be really careful there. So let's see. Going to double check. 9, 19, 24, 30. There's 30 days altogether. If you're working on one of these and you don't get the correct number of days in a month, we need to stop and go figure out what the problem is before proceeding, because we need that part to be right for sure. We're going to find a weighted average of all of these balances on all of these days. So to do that, a calculator is really handy. We're going to do all of these products. 250 times 3 will give us 750. 345 times 6. I'm doing them right now. This is 2,070. 333 times 10 is 3,330. 353 times 5, 1,765. 378 times 6 is 2,268. So we find a total of all of these dollar values on all of these days. And then we're going to add all of those totals up and get a giant total down here. I've forgotten what that is, so I'm going to do that at the same time. 750 plus 2070 plus 3330 plus 1765 plus 2268. I get 10,183. And this process still isn't done. Her average daily balance needs to be between the low end of $250 and the high end of $378. This is way, way, way too big. So we have one more step to find the average daily balance. We'll take that huge total dollar amount and divide by the number of days in the month. So 10,183 divided by 30 days. And you'll get a funky little decimal for that. It should come out to be $339, and if we use regular math class rounding to the nearest penny, it should be 43 cents. So this process of finding the average daily balance, I'm kind of exposing all of you to it. You can see how if you had a very active credit card with lots of transactions on every day of September, this would be a process that would be intimidating to do by hand. A spreadsheet might be your friend in that case, okay? But I wanted you to know where the average daily balance comes from. I think there's a follow-up question behind here. Let me come and see. Oh, Chris's finance charge is 9.8%. Just copying that part. And then 365 days they use. All right, let me pop that back up. All right. So I would not ask this kind of a question on the quiz where you have to fill in the chart and find the average daily balance, but I would ask a question where I give you the average daily balance and a percentage and some information about how they're computing it and ask for the finance charge. So this is actually from last week, or the last class period. Finance charge, that will be simple interest. So we tried out the simple interest formula. The principal is the starting amount that they're going to charge interest on. It's that $339.43. That's what they're going to assess the fee on. The R value, 0.098, because they gave you that extra piece of information about her percentage rate. And then this information about days tells us that when we put the time in here, we'll use 30 days in September out of 365 days in a year. So then a little bit of typing, 339 and 43 cents times the percentage rate times 30 out of 365. And if I round this to the nearest penny, $2.73 is what her finance charge is looking like for the month. So that'll be like a line item on her bill. It'll say finance charge or service charge, $2.73. So that pretty much tackles the Desmos work. We did have some extra practice problems, and so I wanted to kind of share those styles with you. Let me find mine. These aren't the exact ones that we did in class, but I did them with another group. So let me switch this up. All right. So here's one to think about. And I encourage you to pause things and try this on your own and then reveal the solution. A Happy Meal costs $4.59 today. Adjust that for inflation over 40 years. Inflation, that will mean interest compounded annually. So we tried out the compound interest formula. We go fill in the components. We're starting at $4.59. There's the inflation rate that was given. There's the number of years going by, and the ones are for annually. When you compute this, you'll find out that 40 years from now, if we're still doing Happy Meals and they have only been adjusted for inflation, then they should cost about $14.97. So that was one style of review problem. Maybe not review, because today was the first day of compound interest, but it was another example. Here's one. If I told you that a payday loan operation would loan someone $250 for 2 weeks with the agreement that the person will owe a total of $285 at the end of the loan period, we needed to find out what simple interest rate was being charged. This one says simple interest in the problem, and the payday loan idea is a clue that simple interest will come along. So when I look at the simple interest formula, I know I'm looking for the R, and that means I have to know everything else. All right, lots of things going on here. The interest amount is the fee for having taken out a loan with them. It's the gap between the $285 that gets paid back and the $250 that's borrowed. It's $35. So your I value gets replaced with 35. The amount you borrowed, or this person borrows $250. We don't know the rate. And then 2 out of 52 comes because we're using 2 weeks out of 52 in the year. To solve for R, one way is to divide off the 250 right away. And then that leaves us a little messiness here, but let me cover some things up. We will have beautiful cancellation of the 250s. We would still need to get rid of the 2 out of 52. One strategy for that is to multiply both sides of your equation by the reciprocal of 2 out of 52. So that's back to the messiness part. There's the 35 out of 250. We would have had R times 2 out of 52. There's the reciprocal action. We only need to feed these two fractions into the calculator and find the result. And this one came out pretty nice. 3.64 was the R value. But this is a decimal, and so it has to be shuffled over to its percentage format. You can move your decimal point 2 places to the right, or you can multiply by 100. But it's 364%. Ah! So be able to do problems like that. That was one request today. I think I have two more requests. Looking for my cover-up paper. There it is. Find the finance charge on a credit card that charges 15.8% in some month when the average daily balance was $21.50. Finance charge is a clue. This should be simple interest. Simple interest formula. We are looking for the I, the charge, the fee. So we have to know all of the other three components. This P value is the amount that they carried over for their average daily balance. Not the carryover, it is their average daily balance. The R comes from the interest rate that's given. The T, we don't know what month we're talking about, so we'll just use 1 month out of 12 months in a year. When I fill all of this in, I get this. And then I think the final answer here ended up being $28.31. So one generic month out of the year. And finally, let's say a person borrows $5,000 and agrees to pay it back in monthly payments over 3 years. And I give you the monthly payment. I'd like to know what's the total of all of their payments. So the total of all of the payments would be 3 years worth of monthly payments, and they're each $150.08. So 3 years times 12 months in a year times 150.08 should give us $5,402.88. Follow-up question would be how much interest was paid? $402.88. We find the gap between the total that we paid and the amount that we borrowed. That's one way to get there. And in this problem, I think it might be the only way to get there. So there's some insights on the stuff that happened with Desmos and a little bit of review today in class.